Okay, so we'll get started again with George. George is going to talk to us a little bit about PipeWire and Bluetooth, so take it away, George.
Thank you, Kevin. So, hello everyone. Good afternoon. My name is George. I'm a software engineer at Collabora. I work on multimedia applications on Linux systems. I have worked extensively with GStreamer and PipeWire. I'm the maintainer of WirePlumber, which is the session manager of PipeWire. I've contributed to automotive-grade Linux, and I am also new to the BlueZ project, hence the topic of this talk. Today, I am going to talk to you about Bluetooth audio. Before I begin, I want to explain a little bit about Bluetooth, just as a background, so that you can understand everything else. So Bluetooth is essentially a set of specifications. It consists of two kinds of specifications. There's the core specification, which is the central specification that gets the version number that we typically associate with Bluetooth. So when we say Bluetooth, let's say 5.0 or 5.4 or 6, we mean the core specification of Bluetooth of that version. The core specification has the basic building blocks for building Bluetooth wireless applications, and specifies all the low-level protocols and features. And on top of that, we have the profile specifications, the so-called profiles, which describe how to implement a specific use case on top of the Bluetooth core. And they have higher-level protocols, procedures also for using these protocols, what kind of commands to send, etc. And they have their own versioning scheme. And they can be released separately from the core, but they tend to also be released together, drop together. So some background on Bluetooth. Bluetooth is a very old protocol, old specification. It was initially introduced in 1999. That was the first version, but the idea was from 10 years back, from 1989. Initially, it was meant to be a wireless replacement for serial cables, but then, of course, it evolved to include more. The first company to start developing on that in 1994 was Ericsson, which was making mobile phones. And of course, the focus was on mobile phone use cases. The initial version had no audio, version 1.0 in 1999, but then shortly after, in 2001, we had version 1.1 that had a specification for the headset and hands-free profiles, which allow us to connect to a mobile phone with a headset or a hands-free device and take phone calls and talk and hear the other person. That was specifically for phone calls. It was intended for phone calls. So the hands-free profile and the headset profile, they used, as I said, they were intended for phone calls or at least voice data, and they used a certain type of link called SCO, which stands for Synchronous Connection-Oriented Link. That's a type of transport protocol that uses reserved time slots to transmit data. Basically, in Bluetooth, every packet is given some amount of time. Actually, the size of a packet is described in units of time. And it's a time division multiple access system. So the bandwidth is divided into units of time, and then the packets are transmitted within those time slots. Now, SCO is basically has reserved time slots just for voice data, and that allowed us to have voice data transmitted at a steady rate with a capped bandwidth, of course. And it used RFCOM for control. RFCOM stands for radio frequency communications. Makes no particular sense for what it is. It's basically serial over Bluetooth. And the idea was to send 80 commands over serial, over Bluetooth. where the AT commands are basically the commands that were introduced in 1981 for modems, and they are still used today for GSM modems and, of course, Bluetooth HFP. In HFP and HSP, the devices have two roles. There can be, we have the audio gateway, which is typically the phone or your computer, and we have the headset and the hands-free unit, which is what you wear on your head, or it could be your car as well. Like your car is also a hands-free unit. HSP and HFP are very similar. They have very small differences. Basically, HSP is more simple. It has only basic control features. That's the main differentiator, the control features. It can answer calls, hang up, change the volume, and not much else. While HFP has additional commands to dial a number, to put it on hold, to do three-way calls, to activate your voice assistant, because talking to your voice assistant over your Bluetooth headset is also done by placing a call over HFP, basically. That's how it's implemented. And HFP also, well, initially didn't support anything else than the CVSD codec, which is the very basic one, the mandatory one. It has 8 kilohertz of voice bandwidth. But nowadays it supports more because support for wideband and super wideband was added in 2013 and 2023 for super wideband. So it can have good quality audio nowadays. Initially, it didn't have good quality audio. It was very bad. And then 2 years later, in 2003, there was another version, Bluetooth 1.2, that introduced the advanced audio distribution profile, because clearly there were more use cases than just making calls, right? There was also the use case of listening to music, which maybe wasn't there initially, but soon people realized that this was something. So they dropped another profile that works very differently. It doesn't use the synchronous connection-oriented transport. It uses RTP over Bluetooth. And also a year later, in Bluetooth 2.0, there was the specification of the audio-video remote control profile, which added also control commands so that you can start your music, stop your music, transmit a playlist, control the playlist, have information about the current position and duration of the song, and things like that. A2DP was, however, meant only for media playback, and hence it was created so that it is one way only. So you can transmit from a source. Devices have two roles. There's the source and the sink. The source is the transmitter, whatever plays the music, and the sink is the speaker or your headset that receives and plays the audio. It uses the audio-video distribution transport protocol, which is basically RTP modified for Bluetooth. And it can support a lot of codecs. So it's not just one codec, because it's not just a steady rate. It's different. It's like streaming audio on a network. And the basic codec, the initial was the SBC, the sub-band codec. But then there were additions. And now we can have AAC, Aptix, LDAC, Opus, and others. It is typically combined with the AVRCP profile, of course, to have control over your media playlist, but it's not mandatory, it's not necessary. It can also stand alone. You can have just audio. Now, do you notice any problems? Yes, there are many problems with those standards. First of all, the A2DP, the high-quality audio transmission is unidirectional, so we cannot really do complex things like talk also on the phone while we're listening to music. And for modern use cases, sometimes this is a limitation. Some non-standard solutions exist for that. We will see them later, but they're not widely implemented, so it's not something you can actually use. When devices want to use the microphone, they tend to switch to HFP. Right? So you might have noticed you have a headset at home, a Bluetooth headset. You are listening to music, and suddenly you start a meeting, online meeting, and then you start talking, and you suddenly realize that the music sounds really bad. It sounds really bad for two reasons. One is there is a different codec being used, there is less bandwidth, but also there is the problem that a lot of headsets optimize the audio for speech because they think that if you're using HFP, you're going to do voice call, so they turn on a DSP that optimizes the voice, so it optimizes the audio for voice. Now, other problems is that A2DP has high latency, and it's not good for real-time audio. It also has high energy consumption, so, well, of course engineers have worked around that, and now you can have earbuds that can last maybe 4 or 5 hours, but what if we could make them last for the entire day? That would be amazing. And of course we have new tech, new use cases that are not being covered, and companies that make real-world products that are actually there on the market today, they have implemented a lot of hacks around all of that. So for example, you have earbuds. The earbuds are two devices. They're not one device, they're two devices. But neither the A2DP profile nor the HFP profile specify a way to stream to two devices at the same time. So what happens is the system transmits to one of those, and then that receiver retransmits for the other earbud, which is annoying. And then we have things like hearing aids, which are not natively supported, spatial audio, sharing audio with other headsets, talking to your voice assistant, which is implemented over HFP, but it's not like HFP was not intended for that, and more. So to solve all of these problems, the Bluetooth SIG and the companies that work on Bluetooth, they have released a new specification called Bluetooth LE audio. LE stands for low energy. Bluetooth low energy is basically a new Bluetooth stack that was introduced around 2010. And it was focusing on IoT use cases. It's a different stack. It's like a different protocol. So it's almost like saying the difference between Bluetooth and Bluetooth Low Energy is almost like saying the difference between Wi-Fi and Bluetooth. They're entirely separate. But they're typically implemented in the same controller. And there's a formal specification of how to implement them together. So Bluetooth Low Energy didn't have audio. It was focusing on IoT. It was focusing on wearables like smartwatches and things like that. But in 2020, the SIG introduced support for audio as well. And by doing that, they tried to reinvent the wheel, write it all from scratch, get rid of all those old profiles, old limitations, and create a generic audio framework that has a modular design that combines all the current known use cases and also allows for expansion for future use cases. It has, from the very beginning, has lower latency down to 20 milliseconds. 20 milliseconds is very, very good. It's the same latency that you have on your wired headphones or your speakers on your laptop. When you're using a typical laptop sound card, of course. I'm not talking about professional sound cards. And it has enhanced range at the expense of latency, so you can go further than 10 meters, but of course the latency changes a little bit. And it uses a new codec. It's called the Low Complexity Communication Codec, or LC3. In a picture, it looks like this. So we have the Bluetooth LE audio is not one specification. It's a lot of specifications bundled together. The main thing here is the you see on the left, you have the basic audio profile, or BAP. This is what implements the actual audio streaming, and this is the main thing you have to implement, like from an audio daemon perspective, because I'm talking about PipeWire next. This is the main thing you have to implement, the BAP, the basic audio profile. This implements the streaming. Everything else is just control profiles. Like we have media control profile. It specifies how to control your playlist and play, pause, and etc. You have the call control profile to dial, to accept a call. We have the coordinated set identification profile, which specifies how to use multiple devices at the same time, like the earbuds that I mentioned before. Microphone control profile, volume control profile, and then on top we have the common audio profile, which is like a collection of specifications, and some use case specific profiles. We have the telephony and media audio profile, specifically for devices that implement either telephony or media or both, like a mobile phone. And then we have the hearing access profile for hearing aids. So hearing aids are now part of the main standard. And we have the public broadcast profile, which enables a new, very interesting use case, the use case of broadcasting audio to multiple receivers. So we see that LE Audio basically unifies the telephony and media use cases, and it has all the modern ways of controlling everything. No more 80s tech, no more 80 commands, no more old hacks on top of older hacks. And the modern use cases are catered for. We have profiles for that. We have support for hearing aids, and we have support for multiple streams for the so-called true wireless earbuds. These are the earbuds that can separately talk to your device. And we have the audio broadcasting feature, which is marketed as Auracast. And the idea there is that when this is fully deployed, we will be able to go around in rooms where there's a public audio source and use our mobile phone to just join that audio source, just like we do with Wi-Fi today. So for example, in here, we could, in the future, have an Auracast source. So as I'm talking to the mic, you could pop in your headset and just listen to that and leave the room, go outside, and keep listening to what I'm saying. Or if you're in the back and you're not hearing well, maybe you can use that as well. If you have hearing loss, you may be using your hearing aids and have this audio transmitted directly to your hearing aids. That's also cool. There's a lot of new interesting use cases for that. And now let's talk about Bluetooth on Linux. Bluetooth on Linux is typically implemented with BlueZ. BlueZ is the default Linux Bluetooth stack. It consists of two parts. There is the part that lives in the Linux kernel, the kernel drivers, and there is a part which is user space daemons and tools. And you need both to make it work. And then for audio, BlueZ doesn't do audio directly. It doesn't control audio. It doesn't stream audio. So you need an audio daemon to implement that part. And while there are some other solutions as well, but the most featureful and most modern one is PipeWire. PipeWire is, I like to describe it as a multimedia inter-process communication framework. A lot of people know it as the audio server, but it's not just an audio server. It's basically a framework to implement any kind of multimedia inter-process communication. So you can stream media from one process to another, but it also has support for accessing devices, so you can transmit audio to and from a device. since it talks to devices, it also has a BlueZ plugin. So it talks to BlueZ and it figures out the Bluetooth connected devices, and it can connect to those Bluetooth devices. And it implements all the known audio profiles that we have today. So it implements A2DP, HSP, HFP. It implements also ASHA, which is a non-standard profile for hearing aids before the introduction of LE audio. It implements LE audio, of course. And it also implements low-energy MIDI, which is not really an audio profile, but it's related. So if you have digital MIDI equipment, professional audio equipment that uses MIDI, you can also connect that to PipeWire and sync it to your pipelines and your jack MIDI applications. For A2DP, PipeWire supports all the known codecs, starting from the mandatory SBC codec and its high-quality variant, SBC-XQ. Then it has support for AAC, aptics, LDAC. It has support for Opus in two variants. There is the variant that PipeWire developers developed themselves, and before the introduction of the more standardized variant that Google released. So Google implemented an Opus specification, Opus over A2DP specification, and they implemented it in Android. That was just after we had also implemented our own specification. So it's two variants. And we have LC3+. LC3 is the low complexity communication codec that is used in LE audio, but it has been made available also for A2DP with some extra features. It's proprietary, though. You have to license it from Fraunhofer. And we have also fast stream and optics low latency, which are both codecs that try to implement bidirectional audio over A2DP. Remember what I said, there are some non-standard ways to circumvent the unidirectionality of A2DP. And it's these two codecs, they try to implement two directions using the standard one direction link. It's a hack, but it works. However, no real-world devices implement that. So it will only work if you have PipeWire to PipeWire. And maybe some, I don't know, maybe some devices use aptics-LL. Aptics is the proprietary codec from Qualcomm, so I suppose that some Qualcomm chips also implement that, but I haven't seen it in practice. For HSP and HFP, we support, of course, all variants, all roles, all codecs as well, including the recent LC3 super wideband. So that's also LC3. It was modified in a way so that it can be used in HFP with lower bandwidth. And we have a couple of backends for the control part. HFP is two parts. There's the audio streaming part and the control part. So the control part, we have a native implementation that connects with RFCOM to the other device and sends AT commands. And then we have the Ophono implementation, which, well, Ophono is a daemon that came together with BlueZ. It is meant to connect to modems, so it's really what it is best at is enabling modems, and it has support for connecting to HFP devices as well. But well, it hasn't worked very well for that, and not many people are happy with it. So we support it, but it's not really the best you can use with PipeWire. And then there is HSP HFPD, which is an old try to create an independent control daemon, but it's deprecated nowadays. Don't use it. Now, Ophono, as I said, it's a telephony and modem-related daemon. It is good to have an abstraction over modems. And since you can talk to modems over HFP, if you're implementing the hands-free side, you're talking to a modem which is on the phone remotely. It was considered like a good idea to have this abstraction. And until late last year, that was the only way to do HFP telephony. If you wanted to dial or answer a call, that was the only way. Thankfully, we had the opportunity to implement native support for that in the native backend. So nowadays, we have telephony support in the native backend. We have a dbus interface that you can use to make calls. And that applies if you are on the hands-free side, right? If you're on the audio gateway side, where the modem is local, then we have integration with Modem Manager to expose those commands to the remote side. And we also have support to integrate with UPower to exchange battery status, because battery status, for some reason, is also part of HFP. It's also transmitted through HFP. I suppose for simplicity, for like older hands-free devices. Then we have support for ASHA. ASHA stands for Audio Streaming for Hearing Aids, developed by Google. It's a non-standard. It's not a Bluetooth official specification, but it's widely implemented in hearing aids, and of course, Android supports it. Of course, iPhone doesn't support it, so it's one way only. Like it's a closed ecosystem. This is also based on Bluetooth Low Energy, but it's not LE audio. LE audio was developed after. It uses the G722 codec, and it's supported also in PipeWire since early 2025. Actually, I saw some commits very, very recently, like 2 weeks ago as well. So it's in active development. And you can use that to connect you to hearing aids. Of course, that's for compatibility with existing devices. We don't expect people to use it to develop new devices with that. Then we have low energy MIDI. MIDI is musical instrument digital interface. We support that both in server and client. So you can implement either a computer or a gadget that connects to a remote MIDI device, or you can implement the MIDI device if you're doing embedded, if you're I don't know, developing a piano, or actually we had a project at some point where we put PipeWire in a piano, digital piano, for audio, not MIDI, but it was very interesting. It's actually a very viable choice to implement such devices. And now for LE audio, we have basic handling of the basic audio profile, as I said, and we also handle the volume control profile. We have yet to implement microphone control. That's not there, but it should be easy to add. It uses the liblc3 from Google, from Android, which is licensed with Apache 2, and it's a good option, good choice. It supports coordinated devices through extra session management bits. So we have a script in WirePlumber that can link those devices together, because each device, if you have earbuds, the left and the right earbud will appear as different nodes in PipeWire, as different syncs. And you can stream different things to each one. And we have support in WirePlumber to basically group them with a combined sync so that you can stream one thing and then go to the left and right earbuds as expected. And of course, we support broadcast audio as well. Now, that is if you know how to configure it. It's not trivial. And it's not supported by all chipsets as well, all controllers. So this is experimental territory. This is new. And if you know what you're doing, you can get it working. But it's not there yet. Also, it has some problems. LE audio has some problems still. Like the format negotiation is a bit problematic. You have to try maybe all formats. You have to open the device and try formats and see what works and see what doesn't work. There is no good negotiation mechanism. Also, there is a missing reconfiguration. So if you want to change the format at runtime while things are moving, it doesn't work. Also, we don't have accurate presentation delays, and that might be something missing in the Bluetooth spec, but it's under investigation. Presentation delay is how much time it takes from the moment that you play something, that you render something on your player software, until the time that it is actually audible in the air. Typically, we can measure that, but there is no accurate measurement here. And finally, we have a big problem with devices that implement both A2DP classic and also LE audio because there is no profile, there is no specification in Bluetooth that tells us how to negotiate between those two because they are on different stacks, they are totally independent. And if the headset supports A2DP, it usually prefers A2DP instead of LE audio. And the workaround currently is to disable the entire Bluetooth classic stack by telling BlueZ to use only low energy. And then everything goes away, like A2DP goes away, HFP goes away, all the other classic profiles like phone book access and message access and everything, they go away, and then you only have LE audio. We are working on that. So that's the current status. Now what's next? We have a workshop. Actually, it's not tomorrow, it's on Friday. I was supposed to do this talk on Thursday, so that's why I wrote tomorrow. We have a workshop, a PipeWire workshop, that we are going to discuss some of these things, some of these issues. One thing that is of particular interest right now, we're having some discussions. Actually, my colleague Frederick already started working on that, is potentially move all the HFP control into BlueZ. Because it's control, it's not audio, and maybe we can do all of that directly in BlueZ instead of implementing in PipeWire. That would help us do the qualification easier, because Bluetooth devices have to go through a qualification, and they have to pass tests. And testing multiple components of software is harder. So the less components we have, the easier it is, and the more we can automate. We also want to improve low-energy audio and Auracast support. Of course, we want to make it more easy to configure, to have microphone control, to have call control. Right now, we don't have call control on BlueZ, so we cannot really make phone calls using low-energy audio. Another thing that I want to do is desktop UI integration, so that actually Linux desktop users can experiment with these features, can use them in their laptops. Ideally, I'd like to have a call UI to make phone calls. Actually, I've already started working on that a little bit, but yeah, it's in the very early stages. And of course, Auracast control, if we want to join a source from our laptop, how do we do that? That kind of thing. The code base is a bit messy, needs a little bit of tidying up and potentially oxidize, like write some parts in Rust, or at least enable people to write in Rust. That's another topic we're discussing on Friday. How do we write more components in Rust in PipeWire and BlueZ later? And finally, the LE audio spec is not final. There is more stuff coming. We know that SIG is working on more updates, and that will be coming very soon, and we need to be ready to implement them. Thank you very much.
Questions?
Over there? Up there, Kevin?
Thank you. So you talk about a very interesting feature for Bluetooth, like the Auracast, or the ability to have two headsets connected to one source. When do you think you will be able to see this kind of feature on the market, on the commercialized products?
It's already on the market. There are some headsets that support it, and there are some Bluetooth controllers that also support it. So very modern Intel controllers support it, and some NXP ones, and I think Qualcomm ones, they support it. So, and if you look at operating systems, Microsoft added support for that in Windows in last November, so 6 months ago. Android added support for that in March, 2 months ago. And there are devices, if you search the internet, there are some like independent companies that make equipment for like conference rooms, etc., that already have integrated that feature. So it's a matter of, it's already in the market. It's a matter of propagating as people buy more devices, newer devices. It will become more common.
But the feature can be deployed with updates, or there is some component needed.
Yeah, so you need some hardware support for that. It's not just software. From a software perspective, of course, you can update, but from the hardware perspective, if your laptop doesn't have a controller that is capable of Forecast, then it won't work. You need a fairly recent controller, like one from 2023, late 23 or 24 at least, something like that.
Okay, thank you.
Mark?
What is the state, if there is any support for it, for A2DP offloading when the Bluetooth chip receives the raw audio stream and does the A2DP encapsulation? Is that supported in PipeWire? Is there a plan to support it? Does it even make sense to support that?
Yeah, of course it makes sense, yeah. I haven't seen it in practice, so yeah, we don't support it for A2DP specifically, but we support it for HFP. That's more common. HFP controllers typically do their own audio, and yes, we have support for that.
Okay.
Hello. Are there any how the synchronization between different speakers is actually done? Is it somewhere on Bluetooth level? Is it somewhere before? What is the magic?
Yeah, you mean like if you have the earbuds that I mentioned before that have to be synchronized? Yeah, that's in the Bluetooth controller. That's implemented in the Bluetooth protocol.
Okay.
Yeah, it's basically how the transmission works. There are some specific timing constraints that devices must implement to render the audio, and yeah, I don't know exactly the details of that, but yeah, it ends up being synchronized.
So on the Bluetooth level is not a peer-to-peer connection, but it's kind of broadcast connection?
Yeah, it's also the same for broadcast. So you transmit, there is no feedback from the devices, so it goes one way. But there are some timing constraints, like from the time that the packet was sent, there are timestamps, and then you have to render in a specific time frame within a couple of milliseconds, something like that. And that's how they synchronize.
Okay.
If I may be oversimplifying that, of course, yeah.
One more question? We have a question from the Matrix channel.
All right, so our very first remote question today from Philip Dylan Glionek, who says, great talk, George. You mentioned only some chipsets are supported. Is there a list of validated chipsets which PipeWire runs well?
No, the answer is no. This is all very new. I know that the recent Intel controllers work, but yeah, that's what we have tested with, like very recent. From the BE series, I know that they work, and the AX something. Maybe Frederick knows better.
From Intel, it's AWA series, AWA 200 series that may support it depending on its firmware.
Yeah, of course, yeah, depending on the firmware, that's a key for, at least for Intel controllers, right? You may have the controller on your laptop, but it won't do LE audio or Auracast unless you have the latest firmware installed. Of course, there are other companies that make controllers. I don't want to monopolize Intel here. Yeah.
For the AAC codec, I noticed the FDK one was supported. Are there any plans, or is it okay to add support for GPL-based, FFmpeg-based AAC codec?
There is no plan, but of course, contributions are more than welcome. We can support more libraries, of course.
Okay, thank you.
All right, thank you, George. That's a great talk.
Thank
Thanks.
you.